Welcome to Physics 2049. This video provides an overview of the background information I give only on the first day of class. It's provided for people who missed the first day of class or the first part of the first day of class for some reason, but in particular it's here for people who are new to TCC and might want a second chance at this information, since I do tend to go over it rather quickly in class. The most important announcement for this particular semester is that if you missed the lab that met this week, you will need to get help from your lab partner during Lab 1, and you should see me about getting a copy of the syllabus and a little bit of an overview of what we did with multimeters. We learn how to use a multimeter as a voltmeter, so we're prepared to do Lab 1 next week. In addition, if you have any questions about the syllabus, which is available only on Canvas, please see me during my office hours so you can get those clarified. Now, as usual, my first announcement is about whether you're in the correct class. This is calculus-based physics for engineering majors and people in the physical sciences who need to know it for their physics or chemistry or biochemistry and perhaps even geology majors. Engineers make up most of this class, so the examples tend to come from engineering, particularly electrical engineering, and the basic physics applications that physics majors need to know. You are still expected to know the basic mechanics and vector skills that are taught in Physics 2048. In addition, you're going to use a lot more calculus than you did last semester. But I emphasize this is calculus-based physics for electricity, magnetism, and circuits. That's foundational material for engineering and physics. Again, if you're new to this textbook, but even if you haven't looked at it in a little bit from last semester, you should review the IDEA approach that's on page 8 of the first volume of our textbook. That provides the basic foundation for how we approach problem solving, a very nice method that was developed by our textbook author. So again, if you're new to this textbook, you should read that quite carefully, but even if you're coming back after a break, you should look over it and see how it applies to specific things that we do this semester. We do use calculus, so I assume everyone knows the chain rule. We'll also set up some application integrals like ones that are typically done at the end of Calc 1 and again at the beginning of Calc 2. If you somehow missed some of that or forgot a lot of it, you'll need to pay particular attention to that topic in this course, and be sure to ask me about it in office hours if things in class aren't clear to you. We also do a great deal with vectors, some of which is not provided as clearly in our textbook as it is in your calculus book. So even if you're not in Calc 3, you should look at section 12.2 in Stewart to see how dot products and cross products are done in full vector notation. As in the past, calculators are limited to things that are not graphing calculators, things that cannot store equations, so you may not use a TI-83 on exams in this course. Only a standard, say, 2-line scientific calculator, such as ones that I've described in some detail on the course website. One thing that is a bit different is we use a great deal of scientific notation this semester, so it could be that the calculator you used last semester and found perfectly adequate is not suitable for this course. In that case, you should look seriously at getting a much better calculator that handles scientific notation, particularly what's called engineering notation, in a natural way. You might want to talk to fellow students about what they find easy to use. Most of the important material in this class is on Canvas. In particular, as last semester, the full syllabus is on Canvas. I will hand out a one-page version in class which has the calendar on it as well as some background information about the course, but the real information, in particular the grading rubric used on exams, and information about using Lon Kappa as well, is only on Canvas. That's also where you'll find advice from former physics students. Even if you think you know what you're doing in these kinds of classes, I recommend that you go read that. You probably remember the advice that you gave the students who are taking Physics 2048 this semester. It's pretty much the same in this class. You do need to read the book, start homework early enough that you know to ask questions in class. Don't procrastinate. But there are some things that are different from the kinds of advice you gave students for Physics 1, so pay particular attention to the differences between the two classes. when you're reading the information about the advice that the students gave you from last semester and previous semesters. And of course, some of them probably remind you to read the syllabus, so be sure you do that. This course is required for engineering majors and a number of other science majors because it's the foundation, particularly for the electrical engineering circuits part, that every engineer needs to know. Engineering majors are expected to pass this class the first time they take it because it is easier than the classes they take in engineering. Everyone requires these courses because they are foundational. Florida State and FAMU, however, don't reject students based on this course. They expect their majors will pass it on the first try, but they'll allow you to take it as many times as necessary at TCC before you transfer. That's not true for all engineering schools, and it's not even true for other science majors at Florida State. Other schools will treat it just like FSU does Physics 2048 and may reject you if you can't pass it on the first or second try, or if your grades are too low in the course. Science majors in the physical sciences, where this course is required, the failing grade in this is counted against you just like it would be in any other course for your major. They have a limited number of attempts that they'll allow you to replace failing grades, and that applies to Physics 2049 if it's required for your major. So in some respects, this course is a more significant course for physics and chemistry and biochemistry majors than it is for engineering majors at Florida State. We use Lon Kappa to do homework. The website's the same as before. If you're new to this whole program, you should get a study partner who took Physics 2048 here at TCC. If you've read the advice files, you realize that you need to start doing the first homework set today. And that's for two reasons. One, just to get started on it. Number two is to be sure you still know how to get into the system. The username is the same as our email name. Just say Smith123, but with all of the letters in lowercase and nothing else after that name. The password is explained in class and in the syllabus. I won't say anything more now, but if you've forgotten your password, send me an email from your TCC account, and I'll deal with that. Log in, see if you can do it, see if your system is working for you, and get started on the homework today. So, go get started on your homework. That includes reviewing the syllabus and the advice files on Canvas. You should log into Lon Kappa and do the first couple of problems there. They're pretty straightforward. Your reading includes section 21.1 about electric fields and field lines, and also strategy 20.1 from chapter 20 about how we calculate electric fields and forces. And of course, you should start learning the equations that we're going to use, in fact, have already used in the first day of class.